And welcome to 10.3 Percent Composition and Chemical Formulas. Now that you know how to do mole conversions using your molar roadmap, we're going to show you how to analyze a compound and determine a chemical formula. We're going to start off by showing you how to calculate a percent composition. Now, a percent composition, let me go ahead and get my pen ready here. There we go. A percentage is going to be the same regardless of the application. It is always part divided by the whole times 100%. And so if we're going to calculate a percent composition for a compound, and by the way, this is by mass. A percent composition by mass will be the element mass, the total mass of an element, divided by the total compound mass, times 100%. The mass of the element is the part, the whole is the total mass of that compound. Let's go ahead and use potassium dichromate as our example here, where you have 2 moles of potassium, you have 2 moles of chromium, and then you're going to have 7 moles of oxygen in the compound. And so let's go ahead and determine by mass the percentage of each individual element. Starting with the potassium, you have 2 moles of K. Each mole of K weighs 39.10 grams. And so in potassium dichromate, you have a total of 78.20 grams of potassium. Taking a look at the chromium now, you have 2 moles of chromium. Of course, we got that 2 from right here. It tells us 2 moles of chromium. Each mole of chromium has a mass of 52 grams. So that means that we have 104 grams of chromium in each mole of potassium dichromate. And with the oxygen, we have 7 moles of oxygen, getting it from right here. Each mole of oxygen weighs 16 grams. And so 7 times 16 gives you a mass of 112 grams of oxygen. And so when you add up those masses, you take your 78.2 plus 104 plus 112, add them up, that gives you a total mass of 294.2 grams total. Now, the percent composition of each element is simply going to be the parts divided by the total times 100%. So for potassium, it's going to be its part divided by the 294.2 grams total times 100%. So that 78.2 divided by the 294 times 100% is going to be 26.6%. So that is the percentage of that compound by mass of potassium. We'll do the same thing with the chromium now. Take the part, 104, divided by the total, 294.2, times the 100%, and that gives us 35.4% chromium. And finally, we'll do the same thing with the oxygen. And so the 112 divided by 294 times 100% gives us 38.1% oxygen. And so now we can tell it's about a quarter potassium and it's more than a third of chromium and oxygen. Now when you add these up, you should get a total of 100%. In fact, in this case, we do get 100.1% due to roundings, and that's okay. So those are the percentages by mass of each element in that particular compound. Now let's try another one. Let's try something a little bit smaller. We'll try water for our second example. H2O. Now with water, let's scroll down and give ourselves some room here. Water has 2 moles of hydrogen and it has 1 mole of oxygen. I guess if we want to, we could do this in the colors. So why don't we go ahead and do that. Again, we have 2 moles of hydrogen, and that comes from that 2 right there. And once again, we only have 1. Of course, there's no number there, but it's implied then that we have 1 mole of oxygen. So we need to figure out what the total mass, or the mass of each component is, get the total mass, and then move on from there. So using the molar mass, hydrogen weighs 1.008 grams per mole, and so that gives us 2.016 grams of hydrogen in every mole of water. With the oxygen, oxygen weighs 16 grams per mole, and so therefore 1 mole of water is going to contain 16 grams of oxygen. And when you tally those up, and we'll just quickly do that, you get 18.016 grams total. Now we're not worrying about where we're rounding these numbers to right now. We'll just add them up. To calculate the percentage, the percentage will be the part that's that element. In case of hydrogen, is 2.016 grams divided by the total, 18.016 grams, times 100%, and we're getting a percentage of 11% hydrogen. Do the same thing with oxygen now. The 16 grams of oxygen divided by 18.016 grams times 100%, and that's going to be 89% oxygen. So the vast majority of water is oxygen. Now looking at the equation, or the formula, you might say, well, wait a minute, there's twice as much hydrogen as oxygen, that's why it's H2O. But that is telling you the number of atoms. That's not telling you the size of these atoms. In fact, if you're to draw a diagram that illustrated what water would look like, oxygen, now this is not an O, it's a sphere, oxygen is 16 times bigger than hydrogen. So oxygen might be that big, while the hydrogen might only be, say, this big. And in fact, it would be actually smaller than that relative to the oxygen. So the water molecule might look something like that, where most of it is going to be the oxygen. Only 11% of it will be the hydrogen. In the next podcast, we're going to take a look at 2 more percent compositions. We'll see you next time.